All right, well, here's what we are going to do. We're going to continue on with Coulombs law. And again, I'm going to look at the interaction between three charges. So a little more dynamics here. And so the question is that we have two charges, Q1 and Q2, there we go, that are separated by a distance of 6 meters. Throw that in there. All right, now a third charge, Q3, is put in the, well, I won't say the middle, put in somewhere in between them, where the net force exerted on Q3 by the other charges is 0. So what we have here with a net charge of 0 is, a net force of 0 is an equilibrium, where the third charge is stuck in the middle, assuming, say, that Q1 and Q2 are fixed, stuck there. Q3 could move around while the forces would be balanced, and so it would stay there. And so what we want to do is determine the location of Q3. All right, so here's what we have. Like I said, we've got our three charges. I've got all the information down there, except for I could say that the distance, if it's 6, all from number 1 to number 2 here, and this is x, well, this missing piece here, this distance, I could find by taking x from 6, or 6 minus x. There we go, we'll put that in there. Now, as I mentioned, is that when we look at the net forces being 0, that means that if I look at the force, we know that Q1 is going to pull Q3 to the left, right? Because they are opposites, and so they're going to attract, but yet Q2 is going to pull it to the right. And so what happens here is, in this situation, is that the force on 3, which is our middle charge here, by number 1 is equal to the force of charge 2, the force on 3 by charge 2. And so Q2 and Q1, one's pulling to the right, one's pulling to the left, but those forces have to be equal. Now the charges are not equal, which means the distance has to change a little bit. And that's what we're going to figure out, is that distance. In fact, I'm going to find out this x value, because if I know x, the distance between 1 and 3, well, then I can substitute in here and find the distance between 2 and 3. All right, so now on that note, I'm going to use, of course, Coulombs law, which is Fe is equal to K times Q1 times Q2, which just means 2 charges, divided by R squared. All right, so if I'm looking for the charge on 3 by number 1, here we go. I'm going to substitute in here. So I have my K value. I'm just going to put K. Charge 3 is 3 times 10 to the power of negative 6. Charge 1 right there is negative. I don't even put in the 4 or the negative sign again. The charges are just telling us, the sign is just telling us which directions, or allows us to figure out which direction things are going. All right, and then divided by distance squared. So the distance between 1 and 3 is x. So it's going to be at x squared. Now, that's going to be equal to the force on 3 by number 2, which again is going to pull it to the right because these opposites are going to attract. So I'm going to have my K value. All right, I have charge 3 there, which is 3 times 10 to the power of negative 6. And I've got my charge 2 here, and once again, I'm ignoring the sign because the sign just helps me figure out what's going on in terms of which way it's pulling. All right, now the distance between them, 6 minus x, and it's squared. All right, now, these two are equal to each other, but here's what I can do. They have a k on both sides. I can divide both sides by k. That helps out, simplifies things. All right, they both have a 3 times 10 to the negative 6 in them. And so I'm going to divide both sides by 3 times 10 to the negative 6. Those are gone. Do I have anything else? Nope, unfortunately not. All right, so just after dividing or canceling things out because they're equal on both sides, now I'm just going to rewrite what I got. So what I have here is I got a 4 times 10 to the power of negative 6 divided by x squared equals 2 times 10 to the negative 5, but divided by 6 minus x squared. All right, now I have a fraction equaling a fraction, and you know what I like to do here. So I am going to cross multiply. So what I'm going to end up with here, and I don't know where I'm going to put it. Let's go over here. So I'm going to have this 4 times 10 to the negative 6 right there times my 6x. Whoa, that should be 6 minus x squared. Whoa, watch out for that. 6 minus x squared, because it's all one term there. All right, then cross multiply, I have 2 times 10 to the negative 5 times x squared. So 2 times 10 to the negative 5 times, x squared. That's a little tough with notation, because that's why we use dots for multiplying. So I'll use dots there, so we don't get our x's and times 10s mixed up. Now I get to this point. Now, to solve this mess, we got some scientific notation here. There's a lot of different ways to do it. Now, I know for me, the easiest way, and I've taught math for 20 years, is see this 10 to the negative 6 and 10 to the negative 5. The easiest thing to do is to eliminate those. And to do that, what I'm going to do is I look at the highest negative number, and it's negative 6. So I'm going to multiply both sides by 10 to the power of 6. I don't know where I'm going to put it in here. There we go. Now, here's what that does. Is this is all one term here. And if I'm multiplying it by 10 to the power of 6, this is again where I'm using my power rules to my advantage. Because 10 to the power of 6 times 10 to the power of negative 6, they cancel each other out. And so now what I've got is just a 4 times 6 minus x squared. But the other side's a little bit different because I have 10 to the power of negative 5, but again, using my power rules. The bases are the same, keep the base the same, add the exponents. Well, a 6 plus a negative 5 is just a 1. So it would be 10 to the power of 1, which is simply just 10. So I have this 2 here. 2 times 10 is 20. And then I have my x squared. If I just confused you, that is the time to ask a question. All right. So now here's where I'm at. Now what I'm going to do is, I'm going to need the room here, so I'm going to get rid of this. All right, so I simplified my equation. All right, I just simply multiplied 10 to the power of 6. I just multiplied everything by 1,000,000 to get rid of those really small decimals. And because I did it to both sides, that's okay, because I did it to both sides. All right, now here's what we're going to do. A little bit of math. All right, so I'm going to have to expand this binomial squared, which oddly a lot of grade 12 students don't know how to do. But what you do is you square the first term. 6 is 36. Then I go 2 times negative x times 6. Well, 2 times negative x is negative 2x. Times 6 is negative 12x. And then I square the x, or negative x squared, or square the negative x, so I get positive x squared. And that's going to equal 20x squared. All right, now, still with the more math going on here. Actually, again, there's lots of ways to solve this. A nice easy way is I can get rid of this 4 by dividing both sides by 4. All right, so that gets rid of the 4. And so now all I have is 36 minus 12x plus 4x, plus x squared. And then on the other side, I have a 20x squared divided by 4. That's a 5x squared. Now, with this, I am heading towards, I'm solving for x here, right? But I have an x and an x squared. I'm headed towards a quadratic formula here. So what I'm going to do is get it into standard form by moving everything to one side and keeping getting a 0 on one side so I can use my quadratic formula. So I'm going to move everything over to the other side. All right, so I've got a 0 on this side now. Here I got my 5x squared. I'm bringing the x squared over, so it's a minus x squared. I bring the minus 12x over, so it's a positive 12x. And I bring the 36 over, so it's a minus 36. All right, now the last step here before I'm going to use my quadratic formula is I've got 5x squared minus x squared. That's a 4x squared plus 12x minus 36. All right, so now I've got my quadratic formula. All right, so, well, I'm going to substitute in here. All right, so your A is always your term in front of the x squared, B is always your term in front of the x, and C is your number at the end. All right, so here we go. X equals negative B. All right, so negative B, well, 12 is B, so it's going to be a negative 12 plus or minus the square root of B squared. B is 12, so we got a 12 squared. Minus 4A. What's A here? 4, okay. And then a C is minus 36. All right, and of course, all over 2A, which is 4. So 2 times 4, I'm just going to put an 8. All right.
Mr. Gates?
Yeah, go ahead.
So, someone in the chat asked if you could factor it first.
Sure,
Sorry for interrupting, though.
Sure, it could.
All right.
To be honest with you, throughout all these calculations, you could probably do this 20 different ways. Yeah, I could totally factor out a 4, but if I did that, about 10 of you are going to ask me why I'm doing that. If you look at my note, I did that. My completed note, I just had a peek. I cheated a bit, and I did that in my completed note. So, but I'm going to do it the other way because I like to do it. Yeah, it's okay. Yeah, you can definitely factor it out. Factor out a 4. But because it doesn't happen that often, that's why I want to just do it straight up. All right, that's just lucky, and well, that's just me. I set that up. All right, so I got minus 12, plus or minus. Let's see here, 12 squared, that's 144. Now, again, I mentioned this before. Here's where I see students always mess up the quadratic formula. It's with the sign underneath. So I got a negative 4 times a 4 times a negative 36. A negative times a positive will give you a negative. Negative times a negative will give you a positive. Now, if I multiply those numbers, because I've already figured out the sign here, 4 times 4 is 16 times the 36, and it's going to be a positive 576 there. Divide by 8. All right, so now we got x equals minus 12 plus or minus. Put an 8 down there. I'm just going to add those two guys together and then take the square root. And let's see here, what do I get? I get 26.83. All right, and then finally, I'm going to get my two answers here. All right, so again, this is the second spot where everybody seems to mess up the quadratic formula. The last thing I'm going to do here is divide by 8. All right, so I'm going to go negative 12 plus 26.38. And then divide by 8. And I get 2 decimal places here, 1.85 meters. But quadratic formula, right? You get two answers. And let's see here. We get negative 12 minus 26.83, then divide by 8. And I get this, negative 4.85. So again, this situation is only happening once, but yet we're getting two answers. And so what answer is right? Well, the question here is that you can't, and then we've had this kind of action before, or idea before, I should say, is that the negative 4.85, it doesn't even make sense. Just like time, length, you can't have negative length. So you can't just cross out an answer, right? You got to say why you're getting rid of it, and you can't have negative length. And we had that again before with projectile motion. in which we got two answers, but again, we had one answer that was negative, and that time usually it was time, and time can't be negative either. So the distance here that we're looking at is 1.85 meters here for this situation, and over here, well, I subtract them, it would be 4.15 meters in between those two. All right, so again, that's just looking at the interaction between Coulombs or three charges using Coulombs law for